Okay guys, this is concept 61, graphing reciprocal parent functions. So what is a reciprocal function? Well, just taking a linear function f of x is equal to x, if you take the reciprocal you're going to get 1 over x. That's it. Okay, that's the parent function. So I want you guys to think, if I'm plugging in, as x goes to infinity, okay, if I'm plugging in all these values for x as I keep going bigger and bigger and bigger, my resulting value for f of x is going to keep getting smaller and smaller and smaller. If you plug in 100 here, 1 over 100, it's a, you're going to get, right, 1 over 100, you're going to get 0.01. If you plug in 1000, right, 1 over 1000, you're going to keep getting smaller and smaller and smaller. You're never going to get to 0, but it's going to approach 0. So that's what happens when I go all the way towards the right side. Now, if I approach 0, going this way, if I'm plugging in smaller x's, right, so it keeps getting bigger. So like, let's start, at 1 over 5. Whoops, that's 1/2. So 1 over 5, I have 0.2. Then I have 1 over 4. 0.25 got bigger. 1 over 3, 0.333. 1 over 4. Whoops, not 1 over 4, 1/2. 1 over 2, sorry, so it got bigger. 1 over 1, right, so at x is equal to 1, I have 1. So you can plot that one. That's an easy one to plot, right? So when x is equal to 1, f of x is equal to 1. Now, what happens there is, you can keep going smaller than 1 as we approach 0, right? So what happens when I take, I don't know, take a half, for example. So if x is equal to a half, somewhere there, right? So half is 0.5, and look what happens. It starts to f of x starts to increase. So if I take, let's say, a third, right? We'll just say 0.333. Okay. Now it's 3.0 and so on. It got bigger. Now if I take a fourth, 1 divided by 0.25. Now f of x is equal to 4, so it's going to keep getting bigger. The closer and closer and closer you get to 0, the smaller decimal that you plug in is going to keep going. F of x is going to keep going up. It's going to keep increasing. So this graph, okay, this graph looks something like this. It's going to keep going up as your x's get smaller, and then we saw that as we plug in bigger and bigger x's, the decimal, right, it just kept getting smaller. The value of f of x just kept getting smaller. So it looks something like this. Don't make it too sharp, right? There has to be a curve, right? So it should look something like this. Now those are my positive x values. What about my negative x values? They work the exact same way. So if x goes towards negative infinity, right, you're going to keep getting a smaller negative decimal. If x goes towards, if x goes towards 0 from the negative side, right, you're going to keep getting a smaller negative decimal here. F of x will generally get into a bigger negative decimal, right? If you plug in negative 1/4, right, 1 over negative 0.25, you're gonna get negative 4, and so on. Okay, so it looks like it reflects, and you're gonna get something like this. Right? At x is equal to negative 1, f of x will be equal to negative 1. So what type of graph is this? We call these hyperbolas because of their characteristics. The domain, notice that I can't plug in 0, right, because I have 1 over 0. It's undefined. So my domain is not all x's, right, that all x's, and the way we could write this too is, here's some mathematical notation for you. This means all x's such that x can't be 0. Okay? Or you could just write x can't be 0. That's fine too. The range, notice that there's nothing I can plug in either, so I could get y is equal to 0. So it works the same way. So the range is really all y's such that y is not 0. Now, my asymptotes, right? Well, if x can be 0, that's a vertical line, right? So then I have an asymptote here going directly through there. The graph is never going to cross it. And similarly, I do have a horizontal asymptote where y is equal to 0. That's my horizontal line. Okay? And that's it. That's the parent reciprocal function. That's the reciprocal parent function, sorry. So standard form of a reciprocal function, same way we've been looking at all the other functions. We have transformations for this guy here. Okay, and hopefully as I write this one in, you start familiarizing yourselves with what the variables or the values of and how they work. So f of x is equal to a over x minus h plus k. H is, just like in all the other parent functions, standard form functions we've looked at, h is your horizontal shift. If you're observing a positive value, that means you plugged in a negative, so you're going to move to the left. If you have a negative value here, that means you plugged in a positive, so you move to the right. If you guys remember, it works like opposite, right? K is the vertical shift. You take that one as is. If it's positive, you move up. If it's negative, you move down. And then A, that's your A is it tells you if you have a stretch or a compression, but also if A is negative, you have a reflection across the x-axis, just like all the others. Okay, if A is greater than 1, you have a stretch, and if A is less than 1, or absolute value of A is less than 1, you have a compression. Works the same way, right? As you plug in, if A is greater than 1, f of x is just going to get larger. If you have something less than 1 when you plug in or when you evaluate, f of x is just going to get smaller, so it's a compression. The vertical asymptote here, notice that just like here in the parent function, I couldn't plug in 0, so that was my vertical asymptote. Works the same way. Okay, if you have some value in the denominator, you can't get 0, so your vertical asymptote will be h, and your horizontal asymptote will be k, because it's just going to get shifted around based on this parent function. Okay, so writing functions here, we have just descriptions, and we have to find what function is describing. Okay, so the reciprocal parent function is reflected across the x-axis, so that immediately tells me I have a negative, right? I'm going to have a negative in front, and it's translated 4 units to the right, so I'm plugging in a positive, so it should stay negative in its form, and then 3 units down, and it says write an equation to represent the new function, identify the asymptotes. Okay, so f of x, I would have, there's no stretch or compression, so it's just 1 over, but it says it's reflected across the x-axis, so I have negative 1, okay, and then 4 units to the right, so I plug in a positive, so x minus 3, because I plug in a positive. Whoops, no, I read this wrong, right? It's 4 units to the right, sorry. Yeah, sorry for that mistake. It's 4 units to the right, 3 units down. So minus 3. And then it says identify the asymptote. So what's my asymptote right here, right? It'll be 4. So vertical asymptote, x is equal to 4. And yes, please write x is equal to 4, because that tells me it's a line, okay? Don't just write 4. Horizontal asymptote will be, it's just k shifted down, right? So it's just negative 3. So it's like shifting this at 0 down to negative 3. Okay? So that's it. That's the first one. The second one says the reciprocal parent function is vertically stretched by a factor of 2, then translated 7 units up and 1 unit to the left. Write an equation to represent any function, then find the asymptote. So f of x, so it's stretched by 2, so my a is now 2, there's no reflection, so it's positive, and I'm going to have x, it says 1 unit to the left, so I'm plugging in a negative 1, so because it's minus in its form here, I'm going to have plus 1, and then 7 units up, so plus 7. My vertical asymptote, what do I plug in here that would give me an undefined value? I would have to plug in negative 1. So x is negative 1. That would be my vertical asymptote. My horizontal asymptote, what's my horizontal asymptote? It would be shifted up from 0, right? So y is equal to positive 7. Okay. Number 3 says a reciprocal function has a vertical asymptote located at x is equal to negative 2 and a horizontal asymptote located at y is equal to 5. Write an expression that could represent this function. That's because there's really multiple functions you can write based off this. You could write some that have vertical compressions, stretches, reflections, so as long as the two asymptotes hold, and we could just write the basic one, right? If there's going to be one at negative 2, then you're going to have x plus 2 on the bottom, right? The asymptote here would be negative 2, that would give you an undefined, and then horizontal asymptote is located at y plus 5, so it's just plus 5. Again, multiple answers for this one here. This is one of them here. Alright, so moving on, I should mention that I am not going to allow you to use a calculator for this test. So yes, you do need to know how to work these out, okay? And they're not that difficult if you understood the previous page, okay? It says graph each function, identify the domain, range, and asymptotes. So we already know what the parent function looks like. It starts right with vertical and horizontal asymptotes right at the what the axes are, right? So what I want you guys to do is just create a small table just for the sake of it being as accurate as possible. Okay, and I'll plug those values in a bit, just hang tight. So first thing you can look at is just, well, let's use what we know about transformations now, and then and get what these asymptotes are, right? So the asymptote, the horizontal asymptote is at y is equal to negative 2, because it's minus 2 here. Okay, there's no horizontal shift, it's just 1 over x. So then the vertical asymptote stays put. So I know I'm going to have, you can't probably see these on the video, right? I'm just going to have a dashed line denoting my asymptote. It's pretty much the y-axis. The horizontal asymptote would be at negative 2. So I'm going to have another dashed line denoting my horizontal asymptote here. Okay, let me use a different color once I actually get to the graph. So I'm going to use red once I actually graph it. Okay, so then my domain, right, I can plug in 0 here for x. That's going to give me an undefined value. So my domain would be just, you know, all x's except x can be 0. Okay, and then similarly, for my y's, my ranges, sorry, would be my y's. What can I plug in there, right? What's the value that I'm not going to be able to get? So it's basically what your horizontal asymptote will be. That's the y value you can't get. So it's all y such that y is not negative. Whoops, forgot to draw my slashes there. All y such that y can't be negative 2. Okay. So then, why do I have this table? Again, it's just for the sake of accuracy. Okay. You know that your vertical asymptote is right on the origin. So what I want you guys to do is just take a few points, maybe 2 points to the left, 2 points to the right of whatever the vertical asymptote is. And so in this case, if I'm at 0, I definitely want to plug in 1 and 2, and then negative 1, negative 2. Okay. When I plug in the positive 1, I get 1 over 1. When I plug in right here, right, and you can feel free to put these in your calculator and use the vars function so you can evaluate. But again, just exercise those mental skills, because I won't allow you to use a calculator. Anyway, plug in the 1 here, you get 1 over 1, which is 1. 1 minus 2, you get negative 1. So at x is equal to positive 1, you have negative 1. So I plot my first point here. At x is equal to 2, I plug this in here, I get 1 over 2, or 0.5. Minus 2, I get negative 1.5. So at 2, I have negative 1.5. So so here's 2, and I have negative 1.5, so it'll be somewhere here, if you guys could see that in the video, right? And then maybe, I mean, you don't have to, but if you took x is equal to maybe 0.5, you can see where an upper point is, but this is fine enough. Anyway, plug in negative 1, you get 1 over negative 1, you get negative 1 minus 2, you get negative 3. So when x is negative 1, you get that y is negative 3, so you have a point here. Okay, that's negative 1, negative 3. Oops, forgot to write it in my table. Then negative 2, plug in negative 2 here, you get negative 0.5. Minus 2, you get negative 2.5. So at negative 2, you got negative 2.5 there. Okay, so what does my graph look like? Oops, let me make this more bolded. It's gonna look something like this. And I did not mean to curve that there. What makes it hard is sometimes looking at the feed and making sure it's looking good. And that causes me to mess up on my graphs. So don't forget to draw in your arrows. It tells me that it keeps going, right? And then just trace it along the asymptote. You don't have to, I mean, you can, if you have more steadier hands than me, you could probably draw this getting closer and closer and closer to the asymptote, but not actually cross it, right? But this is fine like this. And anyway, that's it. That's what this graph looks like. The next one, so I don't have a vertical shift, right? So instantly I know my horizontal asymptote would be staying put. It's at y is equal to 0. So then my range would be all y such that y is not 0. Okay, my vertical asymptote, I have a plus 3 here, so I plugged in a negative 3. So I have a shift of negative 3 going towards the negative side. So my vertical asymptote would be negative 3. So then my domain would be all x's such that x can't be negative 3. I plug it in, I'm going to get 1 over 0. It's undefined. Okay, so then let's draw those dashed lines indicating where my asymptotes are. So I have one, my horizontal one again stays put along the x-axis. That's y is equal to 0. At x is equal to negative 3, I have it here. And please, when you do it on your end, when you do your classwork, make sure that it's clear, okay, that I can identify clearly what your asymptotes are. So then create your table. Take 2 values to the left, 2 values to the right of the asymptote. So I have negative 4, negative 5, and I'm going to have negative 2 and negative 1. You're not restricted to these. You could like I could have used 0, for example, if it just makes it easier to plug into. But anyway, so when you have let's see, negative 4. Okay, if I plug in negative 4 here, I'm going to get 1 over negative 1, which is just negative 1. So at x is equal to negative 4, I have negative 1 right here. At negative 5, let me see, so that would be the next point there. Negative 5 here, I'm getting 1 over negative 2, which is just 1 over, sorry, negative a half, which is just negative 0.5, or yeah, whoops, forgot my sign, negative 0.5. So I have a point there. At negative 2, I get 1 over positive 1, which is just 1. So at x equal to negative 2, I have a point there, positive 1. And then when I plug in negative 1 here, I get positive 1/2. So at x equal to negative 1, I have 0.5. That's the positive one. And then now I can trace in carefully my graph, and this is what it looks like. Okay, that's it. That's all there is to it. The rest of these problems, feel free to continue watching, but the pattern is the same, right? I have some vertical stretches here. All it does for, let me see, yeah, it's 6, 7, and 8. All it does is when I create my table, you'll see that, well, your points get shifted around, but the overall look of the graph stays the same. So here I have no horizontal shift, so then my vertical asymptote stays put at x is equal to 0. So then my domain is all x's such that x is not 0. Okay, because I can't plug in 0. My horizontal asymptote, I do have a shift going up at 1, right? So then my range, what's that y value I can have then? It would be at 1. Okay, let's trace my asymptotes. So my vertical one stays along my, it's gonna stay along my y-axis. Then my horizontal asymptote shifted up 1. So I have that there. Then let's create a table. So let's take, this one's easier, 1 and 2, and then negative 1, negative 2. So when I plug in 1 here, I'm going to get negative 4 plus 1, which is negative 3. And then when I plug in 2 here, I get negative 2 plus 1, I get negative 1. So again, important for accuracy, right? So at x is equal to 2, I have y is equal to negative 1. So yeah, here I have that point there. Oh no, sorry, not there, here. Disregard this upper point. It's actually this one right here. That's 2 comma negative 1. At x is equal to 1, I have y is equal to negative 3. So 1, 2, 3. It would be here. No. What am I doing? No, that's right. That's right. So again, disregard this point here. Pause and double check. Let me know if I made a mistake. At x is equal to 2, you got negative 1, which is this point here. At x is equal to positive 1, I got negative 3. So it's this point here. Okay. At x is equal to negative 1, I plug a negative 1 here. I'm going to get positive 4 plus 1, I get 5. So at x is equal to negative 1, I get that y is equal to positive 5. So 1, 2, 3, 4, 5. I have a point there. 1, 2, 3, 4. Oh geez, I messed up again. You know what's throwing me off? The asymptote shift. Okay, so counting up from the actual axis, I get here, not that point. At negative 2, negative 4 divided by negative 2, I get positive 2 plus 1, I get 3. So at negative 2, I have positive 3. So 1, 2, 3 right here. Again, I apologize. Let me draw little X's over the 2 points that I made a mistake on. Okay, this one and that one. Now I can connect these two dots, and you might notice that something else is different here. Okay, first of all, they seem to kind of open a little bit further away from, they seem to be a little bit further away from like what would be the center of where like the horizontal asymptotes meet. Okay, that's because I have a stretch of 4. Okay, so that looks right. And also notice that these graphs here are in the first, well, not just in the first and third quadrants, right, because there was some shifts going around, but this time I have it on the upper left and lower right as opposed to the upper right, lower left. And that's because I have a reflection across the x-axis. So the one that's usually here goes here now, and the one that's usually here goes here now. Okay, so that's the way this one worked out. So yeah, that's why we do our table, and that's why we have these more accurate points. Okay, make sure you're doing this neat. Come in a test or a group assignment, whatever it is, any sloppiness will be considered a mistake. Okay. Alright, number 7, I have a horizontal shift of 2 because I have -2, so then my vertical asymptote is that x is equal to 2. Therefore my domain, I can't plug in a 2 here because that gives me 0. It's all x such that x is not 2. Okay, my range, I have a downward shift of -2, so then my horizontal asymptote is at -2, and then my range is all y such that y is not -2. So then let's graph my asymptotes here at +2, so I have one here. Apologies if you guys can hear my sister. Okay, so I have 2, and then my horizontal asymptote is at -2. So those are where my asymptotes are there. So then my table, so because I'm at +2, I'm going to plug in 3 and 4, and then I'm going to plug in 1 and 0. So when I plug in 3, I get 3 minus 2, which is just 1. So 3 over 1 is just 3. Minus 2, I get 1. So hopefully I don't make mistakes here. Let's see. At x is equal to, it's 3 comma 1. So 1, 2, 3, 1. So I have a point there. At x is equal to 4. 4 minus 2, I get 2. So 3 over 2 minus 2. So 3 halves minus 2. I'm getting -1 third. No, -1/2. Sorry. So just to show you guys, because I know sometimes you guys say that I'm skipping too many steps. When I plug in 4 here, I get 3 halves minus 2 minus 2, 3 halves minus 2, 2 over 1, then I'm going to make that 4 halves, right? And then that gives me -1/2. So then this one here is -1/2. So at x is equal to 4, so 1, 2, 3, 4, I got -1/2, which should be there. Okay, when I plug in 1, I get 3 over 1 minus 2, which is -1. I get -3 minus 2, I get -5. So at +1, I have -5. So 1, 2, 3, 4, 5. Yeah, don't get thrown off by those asymptotes. So there's 1 comma -5. And when I plug in 0, I get -3 halves minus 2. And then that would be -4 halves minus 3 halves. So I'm getting -7. Right. Let me see. Where can I show the work for this? I'm going to show it down here. So I get 3 over negative 2, or negative 3 halves, minus 4 halves. I'm getting negative 7 halves, and this would be about negative 3.5, right? This would be about negative 3.5. So at x is equal to 0, here, 1, 2, 3, that right there, it's about negative 3.5. So now I can draw this there. Okay. Last two. I have a downward shift of 7, so then my horizontal asymptote is at negative 7. So it's all y such that y is not, whoops, not, I messed this up. All y such that y is not negative 7. My domain, I have a shift towards the left. It's going to be negative 4. So my vertical asymptote is at negative 4. My domain is all x such that x is not negative 4. So I have a vertical asymptote at negative 4, and then I have a horizontal asymptote at negative 7. So all the way down here. So this one here, there's no reflection, so there's going to be a graph here. It's going to be really short. Okay, when this happens, what you could do is just plug in just one value, okay, and that would be the first one going off to like the left of the vertical asymptote. Okay, so I'm at negative 4, so you could plug in negative 5. So you can plug in negative 5, and then negative 3 and negative 2. So then at negative 5, when I plug in negative 5 here, I'm getting 2 over negative 1, which is just negative 2, and I get negative 7. So when x is negative 5, I have negative 7. No, not negative 7, negative 9. Sorry, negative 9. It's negative 9, which is right here. So again, because the space is tight, this is just fine. Okay, you can just sketch it this way, just going through one point. For the other two, when I plug in negative 3 here, I get positive 1. 2 over positive 1 minus 7, I get negative 5. So when x is negative 3, I have negative 5 there. Okay, and then when x is negative 2, I get 2 over 2, which is just 1. 1 minus 7 is negative 6, which is there. So it should look something like that. For, sorry, and I didn't even write it in, so it was shoot, what was it? 2 over 2, 1, it was negative 6. Okay, for number 9, I have a shift to the right of negative 5. Oh, sorry, of positive 5, because it's minus 5 here, right? So x is 5, and then I have a vertical shift of 3, so y is 3 there. Okay, so then my domain and range, all x is such that x can't be 5, and all y such that y can't be 3. So then from here, let's see, my domain is positive 5, 1, 2, 3, 4, 3.5. Sorry, my eyesight is already failing me. So my vertical asymptote is here. My horizontal asymptote is at positive 3. So I have this here. And then notice that I also have a minus 1, right? So there's going to be a reflection. So I'm going to have a graph up here and then one here. Same, seems like a similar situation, right? Space might be tight, so you could just take one point to the right, but I still want you to take 2 to the left of the vertical asymptote. So take 1 to the right, it would be 6. Okay, and then take 2 to the left, it would be 4 and 3. So when I plug in 6 here, I'm going to get positive 1 in the denominators. I get negative 1 plus 3, I get 2. And then when I plug in 4 minus 5, I get negative 1. Negative 1 over negative 1 is positive 1 plus 3, I get 4. When I plug in 3, I'm going to get negative 1 over negative 2. Negative over negative becomes positive, so positive half plus 3, I get 3.5. So 6 comma 2, I have a point there. Okay, this is the one that you could just plot this one and you're fine. Okay, no, I messed that up again. Sorry. 6 comma 2 will be here. I keep counting from the asymptotes. Okay, so I drew an X over the point that I just did a mistake on. So then, here's what my graph will look like. Something like that. And then, for the other points, I have 4 comma 4. So there's a point there. Then I have 3.5. There. So these are my 2 points. And then that's my last graph. This wraps up this concept. Sorry, it's concept 61.